Hello guys and welcome to a new video, this time again from the Microsoft Excel World Championship UK chapter. It's I think a free case. It's called You Can't Park Here Mate. And here it has a little bit of a different structure, 10 levels with easier increase in difficulty. But yeah, especially the later levels are quite hard, so yeah. Hopefully we will get there. So basic XLOOKUP of the registration, in here returning the color. Then playing with time. This is basically time difference. And I show you something first, this what might lead to errors. So what you can do is this minus this and then times 60 times 24, and this is then minutes. But you see here some errors, and if you scroll there deeper, you see here floating point error, and therefore I recommend in this case to round, because using or working with time is kind of often leading to rounding errors. And that's quite an issue when working with time. Here we do this here, minutes parked equals parking end minus parking start, and here we have this in this actual Excel fractional time times 60 times 24, rounded to the minutes, and then we do a simple I'm typing too fast, XLOOKUP for the registration plate, in here returning minutes parked. And then where is this car parked? XLOOKUP for the registration, returning the parking space. This is then a number, and we search for this number in here, returning the name with the match mode exact match or next smaller. So it will next smaller item. So it will automatically revert to the smallest number there. How to overstay your welcome. This is kind of okay, easier. So first we check here for the starting time. So we have here start and minutes parked. And then we need to check how long those cars are allowed to park there. Again, -1. Okay, don't know why it's automatically going to this one. So anyways, so if the car is fine, give the total number of minutes overstayed. If not fine, give the time limit in minutes for the space they parked in. Okay, this is time limit. Is it find? This is, so let's overstay. This is minutes parked minus time limit. And now if this is larger than 10 because larger or equal than 10. Equal 10, then give this, otherwise give the time limit. 10, 120, 26, yeah, looks good. Okay, level 7. This is level 6. Kind of a harder one. Cars parked. Okay, this is, so what I'm doing here is modeling this first. So we have 400 spaces, and then we say, okay, what is the space between those spaces? In this case, we have to, actually this is non-additional. That is an important info. If this is space end, then it's this. And you see here we have a lot of errors here, and we then use this for the if not found. Otherwise, use this. Return on this space here, match mode -1. Yes. Okay, so space 5, 5, 5, 5, 5, yes. And now we do a filter, and we filter our distances. In this case, first for the first option, larger than 10 and smaller or equal than the end space. And we see here 180. But now we have, if you copy this down, oh, you see here calculation error. And we go back to this. So actually, or can do this here. So actually we can say if this is larger than this, then use this approach. Otherwise, filter but we now have to change here something. I think, yeah, because this is currently not matching. This is then to be smaller, and this is to be larger. No. Okay. Okay, we do this separately. 330. It's not okay. What is wrong? So filter the distances if the spaces are smaller than this space here. This is 245. Smaller or equal. 29. Okay, we will figure this out. Plus, if those spaces are larger than this. Okay, why is this not working? Okay, this should be a lot. 340. No. F is okay. It's those should be larger than 353. So here, this is 340. No, I see the error. XLOOKUP can't work that way. I have to actually map in here the sequence. That's the issue, because this is then only using the first if not found. Julian, crucial mistake. Okay, yeah, now it seems to work. Crucial mistake. Smaller than this. Smaller or equal. No, I think here it's larger or equal. Yes. 181. No, why? Yes. No, not in this. Here it's. Here we go. Hopefully. Yeah, this is formatted as text, but we are ready. Okay. Now the warden is working from those spaces to spaces. And yeah, what we can basically do here is do a sum filter of well, first, how do I want to do this? vstack 0 drop -1, and then some filter this here if this is smaller or equal than this, and then at 730 plus this divided by 6, divided by 60 divided by 24, and text oh yeah, in seconds. Okay. Also text, but fast to fix. So this is a little bit more complicated, but can be done quite quick. This, and then I add, because the seconds are given here, for every round that is larger than the first round, 5,266 seconds divided by 60 divided by 24, and this is then leading to the result. Still text, And here we go. Now it is getting a little bit brutal. At least a little bit harder. So I will data table this. Level 9. This doesn't matter, but that I have the structure. So basically we are using this movement, and retard will move indefinitely. So to remove when she's at the last stop, she will start last stop. It will start at the beginning, so to say. And therefore we have to do this multiple times. In my approach, I say it will do it 10 times. Yes, to call, and then space and round, text before. And text after. And now I'm using this formula here above. And simply, I don't need this text stuff here. And yeah, the remaining part will be forced in by a map, lambda S and R. So this is the space, this is the round. The question is, yeah, okay, this is matching. Now, so here check at those certain spaces in your certain rounds. Then I need to do the following. I need to check if the car is still there, or if a car is there, and if it is enforceable. This will be a lot of XLOOKUP, in this case for the space. And returning, in this case the start. And this start park, end park times min state, and I can copy this. Yeah, what you see here, there's some NA stuff, because at some spaces there was no car parked, and also as a hint, there is no space that is double booked, so all those spaces are unique. Minute state, yes. Now allowed minutes and the space, looking here, returning this -1, allowed minutes, it is actually not that intelligent that when I'm typing here -1, that is bringing up this. Okay, yeah, we report it. Anyways, yeah, I have to note this. X lookup -1. Okay, allowed state. So Now start park. Okay, make this to number. Now we have to look when will be the first over park time. So start of park plus minute state divided by 60 divided by 24. And here this is the time the over parking. I think I make this to show this. No, this and then plus 10. Sorry, plus 10. So here actually at 9:35 we're starting to overpark, and now we're searching for the first control for this space after we started to overpark. And I will do this by the following. I will do an XLOOKUP for the space plus the overpark time in the space plus the overpark time, returning space plus control time, so check times, returning the actual check time, match mode -1, exact match or match mode 1, exact match or next larger item. So this is then actually the time, the, how is it called in English? The warden will be there to check. And we now need to check if, she's actually there before the car is leaving, so that she can actually find the car. And this is done by if error, this is smaller than the end park time. This is all in decimals, therefore not an issue. False, false, false. I flew true, and then I filter. Okay, we need the time and the, so the time the check is done, and the let's also include the car number to check. And then we filter a stack of at least a space and control time. It will be find if this is 1, and then unique does also work with multiple rows, and then we have here 28, yeah, might be, and then sort to an increasing order. Does the time match 10:14, 10:48? Yes. Now let's make this text HHMM and do an equal index of this time here, returning the row number, still formatted as text, but we then get here an answer. Now it is getting even more trickier. I will copy this data table and adjust it for level 10. Example 10, and not 1 minus example 10. And here we now have a different starting space and a different starting speed, which is making things a little bit more complicated. So what I'm doing there sequence 400 times, I used here 10 times, but we need even more times. We will check later. 10 times, 11 times 2, starting from here. And now we need the mod function, mod -1, 400 plus 1. And check here, we are starting again at 1. So this is then space round, and round is the same sequence but divided by 400, not starting at a certain point, and rounded up. And we there have our round. Now, what I'm basically doing is I use here an XLOOKUP to get the distance to the next, or between the parking spaces. I know we're starting at 0, therefore I will vstack 0 and drop here the first row out. And this is then the distance in yards, and here we have the second, so time to next stop. But now we have another issue. Here there is a rule, it should actually be other. It takes 1 second to check a car. That's actually the rule. And to implement this rule would mean that we either would have here some trackdown shitty solution, which I do not want to make, or we have to do this solution a little bit differently and need to use a reduce approach. And I use this reduce approach. We're starting at 730, and our array is our space given here, lambda a b. And then we have the following. We have our time, always counting down, and we can now look up for time between spaces. It's an XLOOKUP for b in here, returning this here, which is then divided by the speed in yards in seconds. And then we need to check car t start for the space. It's our b in here, when the parking will start. And when will the parking end? See car t end. It's also an XLOOKUP for b in here, returning the ending time. Now we also need to allowed time XLOOKUP for b in this table here, returning the time limit, match mode -1. Okay, okay, going back here. So we now have the start time, we have the allowed time, we have the end time. and we have distance and therefore the time between the spaces. And we have our accumulator A, and we always know which time was before. And we can therefore simply say A, B, let me think a second. Is there current time before check, and this is actually A plus, oh no, she's not working, so we have to actually check if we need time to check. Time to check needed, and this is if car T end is larger than A and car T start is smaller than A, then I want to return 1, otherwise 0. Divide this by 60, 60 and 24. And we have our check time. And now we check. No, we actually have to walk there. No, this doesn't make sense. A plus, this is in seconds, so make this in actual seconds. Time is A plus the time between spaces, and then this is car end, and this is time, and our result is then time to check needed plus time, and this should an A. Yes, because we cannot look always, so this is then if error is 0, and this should not be reduced, this should be scan. And yeah, the first space, we are at the end of the space, and therefore, does this make sense? Does this make sense? Because actually she does not need time to check this, but the first car, okay, yeah. So what I basically need to do is this minus x lookup for the starting space in here, in here, returning this here. Sorry, Excel, please fix this error. This is an annoying bug. -1 divided by 60, 60 and 24, and the speed. And we then, yeah, okay, we're then starting time at the point. And we can then actually do all this other stuff, not this, but when is the start park, end park, min state, allowed mins, start park, yes, and when I'm then using here the space, Yeah, makes sense. This is fixed, and we can then transfer this min state. Allowed mins is xlookup for the space. In here, time limit -1. Allowed minutes. Overpark time, check and false. When does the overpark time starts? Yeah. Check is, I have to adjust this, so space check and overpark time. This is overpark time. This is the space number as explained in the previous level. This is also the space, and this is the time. Time is now check. But I'm still returning the wrong one, right? Yeah. So this is then time, and this is then time. Oh. Okay. And now I get this true false here. And I can then remove this here and adjust a stack for the space and the time, or simply say yeah, no, let's do this. This is space, this is check time, and this is our check array. Okay, this might calculate a few seconds. Okay, do we have some first ticket 9/11/55? No, not great. Space 200 9/11/55. But actually here there's also a small issue here. I don't know if this is actually matching here, so let's see if we have 49. No, we haven't, which is bad because it should be 49 cars, 49 tickets. Okay, let's debug. Okay, here we have our space, we have our round, we have our check time, which is kind of making sense. So here we then 5266 divided by 360 is 3600 is 1.4. Are we actually? Oh, I forgot something. Sorry. I was at the wrong level. Have I? More. I destroyed level 9, not knowing that I. Okay. Let me fix this. Index. Yes. Sorry, guys. Equals text, and this is then HHMM. Yeah, okay. Now actually let's do here. Do we have 49 tickets? Here we have 49 tickets. Does make sense. And then we use rows for all of this, and we get to our calculation intensive results equals this 121, 140, B1, B4. This might calculate a few seconds. Let's let it calculate. I might be back when it's solved. Okay, I'm actually back with some solution. Well, let's hope everything is right. Oh, 2 levels not? Okay, but those are actually 2 different levels than previously. So let's check. I think I might be 1 off. Yeah. Here I'm 1 off, and here I'm also 1 off. Why is this text? So yeah, it is kind of a little bit of an issue here, I would say, because you should not round at a certain point, but are you then really saying, okay, am I counting everything correct? I think I'm starting here, yes, at the right time. Also here should be no issue. There also no issue. Here also basically no issue. So yeah, I'm reasonably sure that there is kind of, well, I can show you all this, for example. Here we can do a lookup for, this is the check time. We can do a lookup for the time it has overstayed. Or the time it's ending, for example. Here, end time. So you actually, is this end time? No, start time. Here, this is end time. So here we don't see any huge, so the smallest gap here is 1 minute, but yeah, this might be in here 36 seconds. So actually, when someone has rounded either by creating or I'm accidentally rounded something, this might be an issue. And also now let's use the control time here. So the check time, the check time we have, or overproud time or something. So yeah, you can do this indefinitely. You might find the error, or you would not find it. So yeah, rounding issue. Let's go to the bonus questions. How many cars are red Hercules H100? Rose filter, registration. Here this is Hercules. Multiple things. H100, and this is red, and we are at 5. What is the sum of all space numbers of spaces that are not taken? So sum future sequence 400 if not is number x match sequence 400 in our spaces. and it's done. What is the average overstay of all cars that receive fines in level 5? Fines in level 5. Actually it is receiving fines if this is larger than 10. Right. And then larger or equal than 10, sorry. And then use here to call 3. And calculation speed is at the low, and the average excluding the example, sorry, it is not stated but is regular that the example is excluded. Calculation speed, and the average is 34 minutes and minutes 35, sorry, because our actual number is this here, and rounded it would be 35. What is the registration mark of the car with the longest overstay not caught by the warden in level 9? So let's go to level 9. Here this has to be false, and it should actually overstate. So here overstate, and this minus this, and then we filter for a stack of space and minutes overstate. Where it is? Where is it? If this is 0 and this is larger than 10. NA, yes. If error, then 0. Still an issue. The haystacks should not be an issue. Okay. 0. Why is this longer? No, it's not longer. Okay. Because there is no such car. Okay. Interesting. Oh, yeah, this should not be 1, this should be true. And now we have set. Sorry, this should be true, and then we have here unique sort 2 minus 2 1 space 53, and then xlookup at in here, returning the number plate. I'm not 100% sure. Yeah, it's wrong. Okay, I had this the other time around also. Okay, let me quickly check. Okay, this is minutes you have overstayed. actually to get caught, this has to be larger than 10, larger equal than 10, but should not matter. And this here is you are actually caught. Okay. Put here haystack. Listen, overstayed. Longest overstay not caught by the warden. Level 9. No issue there. How do I want to solve this? Sort unique filter. So this has to actually be true. Needs actually to be true, which is right. Oh no, this has to be false. Yeah, of course. Otherwise the car is caught. Nah, yeah, okay. It should not have been 0, it should have been false. And then it would have worked. Space, returning the registration plate number. Hope this is right. And it is, yeah. Now, I don't think I will finish bonus 5, because bonus 5 is kind of hard, even when discounting my 2 not matching games. You might see, that this is not the only issue, because I am light years away from getting the right example. So, sum of all space numbers awaiting capture. So, okay, I should soon save it, otherwise it will break. So, so over part is times state minus state minus this, and we then actually have to filter a stack the space number, only the space number, if this here equals false and this here is larger or equal than 10. And great. Yeah, because we have here a few errors. If error, then 0. And we have here some space numbers. Let's use unique. So actually we have around 29 space numbers that are awaiting capture. And yeah, let's do the following. I'm doing text join of those numbers. And then now we'll run again my script for these games here and turning out all those concatenated numbers. 121, 140, B1, B4. This might take a while, so I'll be right back. Okay, we are back, and let's do the following. Text join. First, I need to have include example 10 and do a text join of all of this and text split by row, group by, count 8 minus 2. And here I have some number when I'm only including those where I'm all the time, which is at least around half of the actual number, or even less. And yeah, I don't know where this issue is exactly, because it cannot be those two cars. And yeah, so yeah, actually no idea where the issue is. If you know this because you have done this case, hi them, reach out. Otherwise, hard case, way harder than expected for a beginner case. But yeah, anyways, fun. Thank you for your attention. See you next time. Bye.